Today we're going to be talking about section 4.8, which is on quadratic inequalities. So far we've talked about linear inequalities, and that's when you had a line, either solid or dotted, and then we shaded above or below it. Then we had multiple lines. We had systems of linear inequalities, where there was a boundary and you had to shade left or right, and there was that double shaded region. Well, now we're going to be talking about quadratic inequalities. And quadratic inequalities are just like they sound. We have some quadratic equation, and we graph it. Always looks like a parabola in some way, shape, or form. And then what we do is we say, okay, well, we can, if we have a, let's say, a greater than or equal to symbol, we know it's going to be a solid line, just like before. If it's just a greater than, it's going to be a dotted line. And we pick some point, and we try that point. And remember, always mine is kind of, I like to see if 0, 0 is either inside or outside of the graph, and then I can plug that in and see if that works in my quadratic inequality, and then we see if it works. And so then we shade either inside or outside of that graph, depending on what happens. Okay? So let's take a look at one right here. Okay, it says graph y is greater than x squared plus 2x plus 1. Now there's a couple different ways we could go about graphing this. Now I think the easiest is to make a table of values, okay? And I always like to put the vertex right in the middle. So remember, we would find what the vertex was. The axis of symmetry is negative b over 2a. Okay, and so we'd say, all right, well, that means my x is going to be, well, b is positive 2, so negative 2 over 2 times 1. Okay, so negative 2 over, and then 2 times 1 is 2. So negative 2 over 2 turns into negative 1. So right in the middle, I'm going to put negative 1 in. And now to figure out what my y is, I put that into x squared, right? And so I say, all right, negative 1 squared plus 2 times negative 1 plus 1. Well, negative 1 squared is 1 plus 2 times negative 1 is negative 2. So now I'm at negative 1 plus 1, and this is going to be 0. And so now that I have this vertex, I know that my vertex is going to be at negative 1, 0. It's right here, okay? And then I can figure out some other points. And so I'm going to pick 2 above and 2 below. So that would be negative 2. I'll make that look a little bit nicer. We have negative 2, and then we have negative 3. We also can pick 0 and 1. And remember, whatever's on the left is also going to be on the right. So I can just put those into my equation. Also, I can put it into my calculator. So that's what I'm actually going to do. I'm going to say x squared plus 2x plus 1, and then I go to my table, and I see, okay, so at negative 3, I get 4, and at negative 2, I get 1, and so then it also repeats itself, so then at 0, I get 1, and at 4, or at 1, I get 4. Okay, so those are just points on my quadratic inequality. So what I'm going to do is I'm going to plot those points. So negative 3, 4 is right here. Okay, negative 2, 1 is right here. 0, 1 is here. And then 1, 4 is going to be right here. Again, axis of symmetry, mirrors on the left, mirrors on the right. Now that I have those points figured out, I look at my symbol. Okay, it's a greater than symbol. And so if it's just greater than, there's no line underneath it, I'm going to have to do a dotted line. And so this is a dotted inequality. Okay, that is dotted quadratic. And now I got to figure out if 0, 0 or a number is either inside or outside of that. So what I'm going to do is I'm going to pick 0, 0. And see, that's outside of my parabola, right? So I put 0 in for y. Okay, so I'm going to do this down here at the bottom a little bit. So 0 is greater than, and now I put 0 in for x. So 0 squared plus 2 times 0 plus 1. Now 0 squared is 0. 2 times 0 is 0. Plus 1 is 1. So now I really have 0 is greater than 1. Is that true? No, 0 is not greater than 1. So that means I'm just going to shade right inside the bowl, right inside my parabola. And so everything within inside the parabola is a solution to this inequality. And everything that's not outside of it is not a solution. Alright? So here is a couple guided practice problems that you can try. I'll have you try 1B. Okay, so 1B it says y is less than negative 2x squared plus 3x plus 1. So we're going to graph this right here. Okay, so let's make our table of values. And again, I want to put my vertex in the middle. Okay, so I figure out what x is. And so that's going to be negative b over 2a. So in our case, that's going to be negative 3 over 2 times negative 2. So I end up getting negative 3 over negative 4. That's just 3/4. Okay, so 3/4 goes in the middle of that. And so then I put 3/4 into my calculator here for x. Negative 2 times 3/4 squared plus 3 times 3/4 plus 5. And I find that my y is going to be 6.125. Now, kind of a nasty number, so that's okay, and we can pick a different number to put in here. So I can put like 0 in, and we'll pick negative 1, and then I can figure out some other points as well. Let's see, I could do like 2, and I could do 3. Okay, so those are a little bit nicer numbers. So I'll just put that into my y equals negative 2x squared plus 3x plus 5. And then I go to my table, and let's see, at negative 1, I get 0. At 0, I get 5. At 2, I get 3. And at 3, I get negative 4. Okay, so it's going to be kind of like obviously because we have that negative 2 in front, it's going to be kind of like a sad face one going down. Alright, so now that I have those points right there, I can just graph them. Okay, so negative 1, 0 is right here. 0, 5 would be right here. 3/4 is like right here, and 6.25 is going to be like right there. Okay, then we get 2, 3, and then we get 3, negative 4 is right there. Okay, so not perfectly lined up, but you can see obviously the type of parabola we're going to get here. This one, I look at the symbol right there, less than, so it's not dotted, okay, or it is dotted, it's not solid, okay, so I make my dotted line, okay, my parabola here, boom, okay, it goes down, and now, since 0, 0 is inside it, I'll try 0, 0, okay, so 0 is less than negative 2 times 0 plus 2 times 0 plus 5, and now the reason we always pick 0 is because this math in here is super easy. Okay, so 0, and then I have this is 0, and that's 0, and so I just get 0 is less than 5. Is that true? It is. So that means everything inside my parabola right here is going to be a solution. Okay, so obviously you see right there. All right, so everything inside of it is a solution. All right, so it says quadratic equations in one variable can be solved using graphs of the related quadratic function. So kind of the same idea. We can use this to solve, right? And so you'll see right here, if it's less than 0 or if it's greater than 0, we can solve it the exact same way. Now, a little bit different though is if it's, you'll see right here, if it's less than 0, you see that right there, my answers are going to be inside, okay, inside my parabola. Okay, if a is greater than 0, meaning it's a positive number. If it's a negative number, all my solutions are going to be outside. Kind of interesting, right? Over here, if it's greater than 0, okay, and I have a positive number, it's going to be outside. And if it's going to be less than 0, meaning a negative number, and it's greater than 0, it's going to be inside. So just something that you kind of notice along the way. All right, here's example 2. It says to solve this equation by graphing. Okay, so the important information we just saw on the last page is you need to find where it crosses the x-axis, right? And so easiest way to do that, okay, would probably be to just put in your calculator and see. Now I'm going to remind us on how to solve this using factoring, and that's perfectly fine. So what I do is I say, okay, well, what two numbers multiply to negative 8 and add up to negative 2? Okay, so that's going to be x squared minus 2x plus 4x, because remember, negative 2x times 4, or negative 2 times 4 is negative 8. Add them together to positive 2. Okay? And so I'm just going to say it's equal to 0 for right now. Okay? And so put parentheses around both of them. Take an x out. X minus 2. Take a positive 4 out. X minus 2. And so I end up getting x plus 4 times x minus 2 could be equal to 0. Okay, so I set them each equal to 0. X plus 4 equals 0, or x minus 2 equals 0. And so I find x is equal to negative 4, and x is equal to 2. So that means at 2 and at negative 4, it crosses the x-axis right there, right? Okay, and then if I wanted to figure out some other parts of my graph, I could figure out where the vertex is. Okay, and now I have 3 points. If I do that, so x is equal to negative b over 2a. So in our case, b is 2, so negative 2 over 2 times 1. And so x is going to be equal to negative 1. Okay, once I know that x is equal to negative 1, I plug it in for x, right? Okay, and when I do that, I find that my vertex is at the point negative 1, negative 9, right here. Okay? And so this is a dotted line, right? Okay, dotted line, right? And so now we look back to the information that we talked about before, okay, and we can try to see if it's going to be within or without, or within or outside of my parabola. Okay, so I can try the point 0, 0, it's right here. I put that in for x. So 0 squared plus 2 times 0 minus 8. So I end up getting negative 8 is less than 0 if I put 0 for x and y. Okay, and I find that negative 8 is less than 0. So everything within is my solution. So that means that my solutions are going to be within when x is negative 4 and when x is 2. So how do I write that as a solution? Well, what I have to do then is say that x is going to be less than 2, but it's going to be greater than negative 4. So here's my solution to this quadratic inequality. And we'll look at another one in a bit. Here's a guided practice problem. I'll have you try 2a now. So if I'm going to solve this, what I'm going to do is I'm going to say what two things multiply to negative 6 add up to positive 5. That's going to be plus 6x minus x minus 6, okay, is equal to 0. All right. And I get x and x plus 6, and then negative 1, x plus 6 equals 0. So then I get x minus 1 equals 0, or x plus 6 equals 0. And so my two solutions I end up getting are x equals 1 and x equals negative 6. How did I get that? Just solve each one of these ones independently. Okay? So now, okay, if I was going to graph it or check it, what I could do is I could just put it on the graph. Otherwise, if you look back to your information, what it said was when it was less than 0, our equation was less than 0, and a was positive, which it is, it's a positive 1, it means that my answers are going to, again, be within my parabola. Okay, and so you can actually try the point 0, 0, it's going to be in between there. And so I get 0, if I put 0 in for x right here and here, I end up getting 0 is greater than negative 6, which is true. It means my answers are within 1 and negative 6. So my answer is going to be negative 6 less than x, which is less than 1. And you can check that on your calculator or if you were to graph it.